Can you see my screen? Okay. Can you see my screen?
Yes, sir.
Yes, sir.
Okay. So just close the window that we see in front of the data file window, okay? Where it is written IBM SPSS statistics. Just close it, clicking on this button. Just close it. Have you closed it? So I have closed it, okay? Do you hear me?
Yes, sir.
Okay, fine. So everybody has developed the data file and you have saved it in a folder. I mean, in your folder. I do not know what is the name, but I requested all of you to generate a folder on desktop by the name of fun. So if the data file is in the fun, then we can open the data file, which is just like MS Word. So go to File, Open, Open. Can you see Open? So you see there are many things. We shall open the data. So select data. Have you selected data? Hello.
Yes, sir.
So select data, then select your folder from here, okay? The folder where you have saved your data file, okay, from here. If you click here, so you can go to your folder, desired folder, okay? But it's just like MS Word. Have you got it? Say, for example, my data file is in the fun folder, which is saved on my desktop. So I will go to the desktop. You can see here is the desktop, okay? So you can see there is a folder as fun. So double click on it. So we can see all the data here. Have you got it?
Yes, sir.
Okay, so you can open it. Just select the file, then click on open. So the data file will be opened, okay? হ্যাঁ শওকত হ্যাঁ আমার লাগবে না ঠিক আছে ওকে আসো ওকে sorry for the interruption. So could you open your file?
No, sir.
No?
Please say again.
Yes,
Give instruction again, please.
আপনি কে বলছিলেন?
Sir, আমি আসমা ফিরদৌসী।
আপনি আপনার ফাইলটা কোথায় সেভ করেছেন মনে আছে? আপনার ফাইলটা কোথায় সেভ করেছেন মনে আছে?
সেটাই দেখছি। খুঁজে পাইনি আসলে।
আচ্ছা, সেটা না পেলে কিন্তু পাবেন না। সেটা you have to remember where you have saved that file. Otherwise you cannot find it. ঠিক আছে?
Yes, sir.
The process of opening the data file is same as we do in MS Word. MS Word to apni janen.
Yes, sir.
Hello. Huh?
Yes, sir. Yes, sir.
MS Word e যেভাবে data file open করেন, it is I mean the data file is opened in the same way, but you have to know where you have saved your data file. Otherwise, you cannot locate it. Okay.
I'm looking for it.
Okay. Okay, fine. So, however, does not matter. So, the thing is that today we shall work with another data file. And I do not know, as I requested all of you to generate a fun folder on your desktop. And I have shared all the materials, training materials with all of you. So I also requested all of you to save all the files in the folder fun. Did you do it?
Yes, sir, I did.
Yes, sir.
Everybody?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay,
Yes,
fine.
sir.
So you already noticed that I have shared 3 data files with you. One is data 3, another is data 4, another is HIV. I think, let me check. Another is data HIV.
Yes, sir.
Okay, data HIV. Now let us open data 3 file. Okay, so you can open data 3 file. I do not know. Sometimes it does not work in other computers. If you directly double click on the data file, it would open in SPSS. However, sometimes it may not happen. To be on the safe side, go to File or just click on this icon. Okay, so go to File, open data. Okay, then go to the fun folder, select data 3, click open. Just open the data 3 file. Could you do it? Could you open the data file?
Yes, please.
Huh?
Yes, sir.
Okay. So a simple thing. Okay, so everybody knows computer. Everybody knows how to use MS Word. It is same like MS Word, MS Excel. Okay. So have you opened the data file 3, data 3 file? Everybody?
Yes, sir.
Okay. So I am also opening it. So I have opened the data file. Okay. Should I proceed?
Yes, sir.
Should I proceed?
Sir, I got a
Yes, sir.
message when I'm trying to open the data file. It says the IBM SPSS statistics is running in Unicode encoding mode.
You have to press yes. Press yes.
Yeah, it will go
Okay.
away if you press yes.
Okay.
Just press yes.
Oh, I see. Okay, just press yes or no, does not matter. Okay. Either press yes or press no, whatever. No problem. So is it okay, everybody? Is it done?
Yes, sir.
Okay, very good. Fine.
স্যার আমি এই ডাটা ফ্রি ফাইলটা স্যার পাইনি স্যার।
না পাইলে এখন কি করব বলেন, আমি তো পাঠাইছি, এখন আপনারা যদি আমার কথাটা না শুনেন তাহলে কি করব বলেন তো? সবার সাথে শেয়ার করা হয়েছে। We shared it not only a single time, several times. আমরা তো several times এটা শেয়ার করেছি।
প্রথম ক্লাসে একটা ড্রাইভের লিংক শেয়ার করা হয়েছিল না, সেখানে আছে।
We have shared everything and we have also checked with you even in the last class. Okay.
স্যার
Yes.
একটু ডিস্টার্ব করি স্যার, এখন আমরা খুলবো আপনারা যে ম্যাটেরিয়ালস ফর স্টুডেন্টস দিয়েছিলেন ওখান থেকে দেখাচ্ছি।
আপনাদেরকে তো আমি ফাইলের নাম বলছি। I am telling you the file name. Name is data3 file. Okay. We have shared this file with you and the name of the file is data3 and it is the unique file. There is no other file with this name. Okay.
সরি স্যার, আমার কাছে ছিল, আমি আসলে ওটা খুঁজে পাইনি তো এখন স্যার পেয়েছি। সরি স্যার।
Okay, should I proceed? Because we do not want to waste our time, you know, with all these things, unnecessary things. Okay, fine. So, can you see my screen?
Yes, sir.
So, if you are in data view like this, go to variable view. Click on the variable view at the lower left corner. Okay. So that everybody is here. So are you here now?
Yes, sir.
Yes, sir.
But
Okay.
I have
Yes.
21 variable. But,
okay. No problem. It might vary because
okay.
I may have deleted something or maybe added something. Does not matter. Okay. So don't worry. So basically, if I look at my data file, you can see that the variable list or the variable names are listed in the first column. So my first variable name is IDNO, right? Right?
Yes, sir.
Yes, sir.
So it means ID number under the label, okay?
Yes, sir.
So the other variables that I have in my data set are age, sex. Forget about sex one. Let me delete it from my computer. Okay, how to delete a data and variable, okay? So if I want to delete sex_1 variable, bring your cursor on 4, click on 4, then click the right button. Okay, then click on clear. So if you do this, then the variable including the data will be deleted. Am I clear?
Yes, sir.
Yes, sir.
Should I repeat? Just click on 4. Okay, click right button, then click on clear. So this would delete not only the variable, also the data with this variable name. Am I clear?
Yes, sir.
So I have deleted it. You can see that then I have a variable by the name religion. Okay, forget about religion 2. Do you have religion 2 on your computer, in your data file?
Yes, sir.
Yes, sir.
Yes.
Okay,
Yes.
okay, keep it like this. So we can see that there are two variables, like one is religion, another is religion 2. Then we have a variable occupation, income, systolic blood pressure, diastolic blood pressure, F history. Means you can see this is family history. Family history of diabetes, okay? Can you see it?
Yes, sir.
Family history of diabetes. We have another variable, peptic ulcer, have peptic ulcer or not, okay? Then we have another variable, diabetes, have diabetes mellitus. We have other variables like pre-test, post-test, okay? We have variables, date AD means
Admission.
date of admission, and date DIS means date of discharge, okay? BW, I do not know whether you have this variable or not.
Sir, I have.
Do you have?
Yes, sir.
Okay, so this is the body weight in kg. Okay, so let me delete this last one. Perhaps you don't have this. So you can see that the variables that we have in data file 3, many of the variables are very similar that we have generated the data file based on our questionnaire, right? Right?
Right.
Many of the variables are similar. But if we, since we are working in the health sector, if we collect data related to health events or other things, we may have several sections in the data file. One of the sections of the data file which is always there is the socio-demographic characteristics, right? We call them universal variables. For all the studies, we actually include the socio-demographic characteristics of the individuals, okay?
Yes, sir.
Fine. Am I clear? Okay.
Yes.
Now, click on data view. Click on data view here. Here. Click on data view. Have you done it?
Yes, sir.
Click on data view. You can see that there are data under each of the variables. Okay. You can see this. Okay. And at the top row, the variable names have appeared. We can see the variable names at the top row. Okay. So can you see this? Click on this button icon. Do you see it? Do you see my computer? Click on this icon. Value levels icon. Okay, have you done it?
Yes, sir.
What do you see?
Yes, sir.
You see, now we see the value levels. Previously, we have seen 1, 2 like this, right? Now we see the value levels, okay?
Yes, sir.
Okay, again, click on this. So you will see only the code numbers. Okay.
Yes, sir.
Okay, so sometimes, you know, after opening the data file, you may see that you see only these things, huh? Okay, sometimes some of the students are complaining, no, I cannot see my code numbers, it is different. I said it's okay, just click on this value level, so you will be back to your code numbers, okay? Fine. Fine,
Yes,
is
sir.
it all right? Okay. Now, let me have a brief presentation. So while we analyze data, first of all, we use our descriptive statistics to analyze the data. Always we use the descriptive statistics at the beginning of data analysis. Okay. So the commonly used descriptive statistics that we use to analyze data are frequency distribution, analyze data are frequency and percentage, right? Then we also analyze the data to calculate the mean, median, mode, etc. Then we try to find the standard deviation of the data, right?
Yes, sir.
Am I correct?
Yes,
Yes,
sir.
Okay. Skewness, kurtosis, I will discuss a little bit later. So let us first concentrate on frequency, percentage, mean, median, mode, standard deviation, etc. Okay? So you see, it's so simple to get all these things in SPSS. So to analyze the data, you can be in data view mode or variable view mode, does not matter, okay? You may be in data view mode, you may be in variable view mode, no problem. Am I clear?
Yes, sir.
Suppose I want to get the frequency distribution of age, religion, and occupation, okay? I want to see the frequency distribution of sex, religion, and occupation. Okay, am I clear?
Yes, sir.
So to have the frequency distribution, go to Analyze. Click on Analyze. Have you done it?
Yes, sir.
Then descriptive statistics, then frequencies, okay? Descriptive statistics, then frequencies. Click on frequencies.
Yes, sir.
Okay, then just click on frequencies. Okay, fine. You can see there are two windows, okay? On the left-hand side, all the variables are listed here. You can see all the variables here, okay? Can you see?
Yes, sir.
In this window, the SPSS first provides the level. Say, for example, first variable is ID number. You can see that it has appeared here, ID number, but in the bracket, it has given this short name. Can you see this? For example, say religion. Religion is religion, so occupation is occupation. Okay, look at the ID number. And in the bracket, it is, it has given the short variable name. This is the default. Am I clear to you?
Yes, sir.
Okay. So if you want to only see this short variable name, you have the option. Okay. The SPSS will not show the label. It's your choice, okay? But I am just showing you the options, okay? So click on any of the variables in this window. Any of the variables in this window, then click the right button of the mouse. Have you done it?
Yes, sir.
Okay. You can see that here, by default, display variable levels, it is selected. Okay, display variable levels is selected by default. That's why we are getting the variable levels. But if you select display variable names, this one, okay, you can see we only now see the short name of the variables. Okay. Okay, am I clear?
Yes, sir.
Click on any variables in the window, click the right button, then select. There are also other options. Okay, there are also other options, but this is not important. But okay, sometimes because I feel more comfortable with display variable names. That's why I'm telling you. Okay, clear?
Yes, sir.
Okay. Now we wanted to have the frequency distribution for age, religion, and occupation. So click on sex, push this arrow. Click on this arrow button. Just click on this arrow button. You will see that the variable sex will be in the variables box now. Okay.
Yes, sir.
So the variables for which you want to have the frequency distribution, select the variables together, or you can do it separately and push them into the variables box. Say, for example, religion, so push it. Okay. Occupation, select it here and push it into the variable box, clicking this arrow button. Am I clear? Am I clear?
Yes, sir.
Yes, sir.
Now just click OK. Click OK. OK. Click OK. Have you done it?
Yes, sir.
So you can see that. Can you see this file now?
Yes,
Another
sir.
window. So in this window, the SPSS will provide all the outputs of analysis. Okay. So we can see that if we look at, ignore this table indicates that there are 210 data. Okay. And there is no missing value. Missing value is shown as 0, 0, 0. Okay. Am I clear?
Yes, sir.
Okay. Now, if we look at the first table, this table shows the frequency distribution of sex. If we look at this table, we can see that there are 133 females and 77 males, and total number of subjects is 210. Clear?
Yes, sir.
And on the right-hand column, second column, it is the percentage. So 63.3% are female, okay? And this is valid percentage. Do you have any idea about what is the difference between percentage and valid percentage? Any idea?
No, sir.
No,
No,
okay,
sir.
I will discuss. And last column is cumulative percentage. Do you know what is cumulative percentage?
No.
Okay, we don't use cumulative percentage. However, I will tell you now. So if we look at the second table where the SPSS has provided the frequency distribution of religion, we can see that out of 210, 128 is Muslim. 58 is Hindu, 26 is Christian. Clear? Clear? Huh?
Yes, sir.
So the cumulative percentage is, say, we can see that the Muslims comprise of 60%, right? 60% are Muslims. Cumulative percentage is if we add, so Hindus comprise of 27.6%. Okay.
Okay, sir.
Yes, sir.
So what is the percentage if we consider Muslims and Hindus together? In that case, it would be 60 plus 27, right?
87.
So it is 87.6. This is what we call cumulative percentage. Cumulative percentage would be this one plus this one, okay? This one. And if we consider Christian in the cumulative percentage, then it would be 87.6 plus another 12.4, which is equal to 100%. Okay? Am I clear? Cumulative means adding up, adding up. If you add with the following categories, okay? Is it all right?
Yes, sir.
Okay, so hope you can understand the third table, occupation, right?
Yes, sir.
Okay. Now, we do not know what is valid percentage and what is percentage as provided by SPSS. Okay. If there is no missing value, then percent and valid percent would be same. Clear? If there is no missing value, then percent and valid percent would be same. Clear?
Yes, sir.
Yes, sir.
Okay. Now,
Sir,
let,
one question. Sir, may
yes.
Sir, if we want to omit the valid person, is there any option that we just on to the frequency or percent or cumulative percent, and we don't want valid percent? Then is there any option?
No, you cannot change the table format. It is the SPSS format. It will also give you the valid percent. Okay.
Okay, sir.
Okay, fine. Now, let me go to my data file. Okay, let me go to my data file, a data view. Okay, so let me delete some of the data. You don't do it, just let me delete some of the data of religion. Say from 1 up to here, I am going to delete. Okay, so I have deleted 6 data. Okay, do you follow me?
Yes, sir.
So I have deleted 6 data. So if I delete the 6 data, you can see that there is a small dot instead of any value. Can you see the small dots?
Yes, sir.
Yes, sir.
Okay. So in SPSS, instead of providing the missing value while entering data, and if the data is missing, you can keep it blank like this. Am I clear? Suppose ID number 1, we did not find the religion. Okay. So in our data, we have defined, you see, 9 as our missing value. Okay.
Yes, sir.
We have
Yes.
defined 9 as our missing value. Suppose somehow the religion was not recorded for the first 6 individuals. In that case, while entering data, you could write 9, no problem. You could write 9, okay? Let me write 39, and you could also keep it blank like this. Am I clear? So I have put 39 and 3 dots. Let us see, what does computer say? Okay. So I will now make a frequency distribution of religion. So to get the frequency distribution, I will go to analyze, descriptive statistics, frequencies, like before, okay? Like before. Frequencies, since I do not want the other 2 variables, say sex and occupation, so I can take them out from the variables box. So to take out sex, just select sex and click this button. Okay, you can see now the button showing the reverse arrow. So if you click it, the variable sex will be transferred to the left-hand window. Okay? Or you can double click on the variable, then this variable will be automatically come to this window. Clear? Say if I double click on occupation, it will be coming back to its original window. Clear?
Okay.
Similarly, if you want to push a variable from this window to this window, you can use double click. Okay, no problem. You can use double click. Okay. Fine. Now, okay, I'm doing okay. Now you see what happens. You can see that the computer is showing now Muslim 122, Hindu 56, Christian 26, okay? Total is 204, then missing 9. This is system missing, okay? 3. Can you see it on my computer? Can you see it?
Yes, sir.
So if I provide the missing value that we have defined in the data set, in that case, computer will show the missing and the value, okay? Missing and the value. But if we keep the cells blank like this, that I have done for 3, in that case, computer will, this 3, okay? Computer will show it as system missing, okay? That's why missing system, okay? Am I clear?
Okay.
Am I clear?
Yes, sir.
Yes, sir.
Now, if you look at the percent, this percent is the percentage calculated with the denominator 210, okay? The percent column calculated the percentage with the denominator 210. Okay?
Yes, yes, sir.
While the valid percent has considered the valid number of subjects as their denominator. Okay? So here the denominator is 204. Okay, am I clear?
Yeah.
Now
Yes,
you
sir.
can see it is different, okay? Percentages are different. Okay, am I clear?
Yes, sir. But
Now, while writing the report, it is your option whether you want to construct the table like this, Muslim, Hindu, Christian, missing. Then you include all these things. you use this percent. But if you want to omit the missing ones, then we prefer to give the valid percentage. Am I clear? Am I clear?
Yes, sir.
Okay. Usually, if there are missing data, missing values, we prefer to give the valid percentage. Okay. Am I clear?
Yes, sir.
Yes, sir.
Okay, so this is the difference. There is no other difference. Okay, fine.
Yes, sir.
Okay. Now, let us try to find the
Sir,
mean
sir.
mid J.
একটু ইয়ে করি, যখন আমি মিসিং ডাটা দিব তখন আমাকে ভ্যালিড পার্সেন্টেজ দেখাবো, তাই না স্যার?
Report kora better. Yeah, we prefer to report the valid percentage.
আর আমি যদি মিসিংটা দিলাম না, শো করলাম না, তখন
The missing টা show করলে তো percentage দিবেন, missing show না করলে দিবেন হলো valid percentage.
আচ্ছা, ঠিক আছে, ঠিক আছে, থ্যাংক ইউ
স্যার। ভ্যালিড পার্সেন্টেজটা মানে মিসিং ডাটাটা এক্সক্লুডেড অর ইনক্লুডেড? ভ্যালিড থেকে
এক্সক্লুডেড, এই যেখানে বললাম না 204, ওটা তো এক্সক্লুডেড। এটা ডিনোমিনেটর 204 আর পার্সেন্টেজের ডিনোমিনেটর হলো 210। তাহলে এটার ভিতরে আছে মিসিং, এটার ভিতরে মিসিং নাই। ওকে,
জি স্যার, জি
স্যার।
ফাইন।
স্যার আমি একটা
ইয়েস জি।
স্যার, এই যে দেখলাম যে আমরা যদি মিসিং ভ্যালু সেট করি তাহলে সেটাও আপনার এই মিসিং এ দেখাচ্ছে, আবার এক্সট্রা যদি আমরা কোনোটা ব্ল্যাঙ্ক রাখি তাহলে সিস্টেম হিসেবে আপনার দেখাচ্ছে। সেক্ষেত্রে আমাদের মিসিং ভ্যালু সেট করার কোনো অ্যাডভান্টেজ আছে, অথবা যদি আমরা এটা ব্ল্যাঙ্ক রাখি টোটালি?
মানে okay, the advantage is that sometimes we may exclude the missing values from analysis. Okay, in that case we can tell the computer, okay, don't select the missing data. ঠিক আছে?
Yes, sir. Understand.
Am I clear? You have
Yes,
two
sir.
options.
Then we can only put the value. Then it will exclude them.
Exactly.
Yes.
Okay. It is better to use some missing value, then it's better to me. But you have also the option, you can keep it blank. Then computer will automatically consider it as a system missing. Okay, clear?
Okay, sir.
Okay. Now let us see how to find mean, median, mode, percentile, quartile, etc. Okay, remember that we find mean, median, mode, percentile, quartile for the quantitative variables. Okay, am I clear?
Yes,
We calculate the mean, median, mode, particularly for the quantitative variables. Okay. However, mode can be used for qualitative variable. Forget about this. Am I clear? Mean, median, mode, we calculate for the quantitative variables. Clear? Okay, am I clear? Please.
Yes, sir.
Okay, sir.
Okay, please. If you do not respond, then I am in trouble. Fine. So in our data, we can see that we have several quantitative variables like age, like income, systolic blood pressure, diastolic blood pressure, etc. Right? These are all quantitative variables. Okay? I'm clear. Is it okay?
Yes,
okay. If we want to find the mean, median, mode, standard deviation, standard error, quartile, percentile, etc., for quantitative variables, it can be done in several different ways. Okay, it can be done in separate different ways. Clear?
Yes,
Clear?
sir. Yes, sir.
The easiest way to do this, I will show you now. Go to Analyze, Descriptive Statistics, Frequencies. Okay. Click on Frequencies. Click on Frequencies. Have you done it? Have you done it?
Yes, sir.
So click on frequencies, okay? Let me click on frequency. Okay, now we shall select the variables. Variables say age, for which we shall calculate the mean, median, modes, etc. Just a minute, let the azan finish.
Okay, sir.
Okay, so we can see that the variable that we have used in the previous analysis is already here, right? Right?
Yep.
So we need to remove it. There are two ways to remove it. As I have mentioned previously, select it and click on this arrow or just double click on this variable, right? Another way is to click on the button reset. Can you see a button reset?
Yes, sir.
So if you click on reset, the computer will take back everything as default. Okay, so click on reset. Okay, you see everything has been changed as default. Okay. Okay.
Yes, sir.
Now select age, push it into this variable box. Have you done it?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now click on statistics. You see there is a tab here, statistics tab. Click on statistics. Click. Should I click?
Yes, sir.
Yes, sir.
Okay. You can see all the options are given here. Your job is just to select the statistics that you want. Okay. Say I want to have the mean. So select mean. Click on here. Click in the box of mean. Okay. Select median. I am interested to get the median. Okay. If you are interested to get the mode, click on mode. Have you got it?
Yes, sir.
So if you want a standard deviation, you see on the description, select standard deviation. Okay. If you want a standard error, select a standard error. If you want minimum, maximum, whatever you want, just select from here. Okay. Am I clear?
Yes, sir.
Then continue. Click on continue. Click on continue. Then okay. then okay. Done? Have you done it?
Yes, sir.
Yes, sir.
So are you see the first table, age.
Yes, sir.
The mean is 26.5. Standard error of mean is this. Median is 27. Mode is 26. Standard deviation is 7.4. Minimum is 6. Maximum is 45. So you see, you can get it within seconds. Huh? Is it
Yes,
okay?
sir.
Huh?
Yes, sir.
Okay. However, you can also see that computer has provided a frequency distribution table of age. Okay. This is the next table, second one. Actually, we don't need this. Okay. Am I clear?
Yes, sir.
So if you want, you can delete this table from your, we call it output window, okay? You can delete it. Just click on this table, just select this table. Have you done, selected it? Just click on this table, single click, don't double click. Single click and push the delete button, then this table would be deleted. Click and push the delete button of your keyboard. Okay, have you done it?
Yes, sir.
Huh? So could you delete it?
Yes, sir.
Okay, so
Yes,
delete
sir.
it. Okay, so you can delete anything from here. Just select it. For example, I have selected this, and if I push my delete button, it would be deleted. Okay, am I clear?
Yes, sir.
Okay. However, we can also do it. We can also tell the computer not to give the second table. So how shall we do it? Go to analyze descriptive frequency in the same area. Descriptive frequencies. Click. Okay. Have you done? Are you here?
Yes, sir.
So until and unless we change the options, computer will keep them. So if you click on statistics, you will see that the statistics that we have selected previously for analysis are still there. Okay. Am I clear?
Yes, sir.
Yes, sir.
It will remain there. It will only be deleted if you push on reset button. Okay. If you push on reset button, then you can remove them. Otherwise, you can remove it one by one. Again, deselecting them. Okay, it's up to you. I'm showing you the options. Okay. Now you can see in this dialog box, at the bottom, it is written display frequency tables. Can you see it?
Yes,
Display
sir.
frequency table, and it is already selected by default, correct?
Yes, sir.
So if you deselect it, clicking on this box, deselect it, then the computer will only give this table, not the second table. Am I clear?
Yes, sir.
Okay, if I do okay, you will see that computer has given only this table and the next table is not given by the computer. Am I clear?
Yes, sir.
Okay, now, just a minute. Can you find the mean, median, mode, standard deviation of income and systolic blood pressure. You do it. Okay. Mean, median, mode, standard deviation of income and systolic blood pressure. Can you do it?
Yes, sir.
Okay, do it, please.
Done.
Done, sir.
Very
Done.
good. Very good. Very good. Okay, very good. Okay. Fine. Excellent. Everybody has done. Everybody
Yes,
has.
sir.
Huh?
Yes, sir.
Oh, okay. You see, it's so simple. It's so simple. Okay, can you please open the book on page 17? Page 17.
Sir, noise হচ্ছে খুব মনে হচ্ছে।
Huh?
Saida,
Noise
Saida
হচ্ছে,
Jamil,
please. Car mic, laptop থেকে, I think the sound is coming from a particular person's laptop.
Saida Jannatul Firdaus, আপনার এখান থেকে আসে।
Okay, so please take care of that one. So, have you opened the book? Page 17. Page 17. Have you opened the book?
Yes, sir.
4.1 frequency distribution. 4.1.
Yes, sir.
So I have written here, I'm just reading from the book. Suppose you want to find the frequency distribution of the variables sex and religion. To do this, use the following commands. Okay? Okay?
Okay, sir.
So now, can you use the book to analyze this data looking at the book? Can you do it looking at the book, or should I give you another one? Okay, let me give you another one. Okay, please go to page 19. Page 19.
Sir?
Page 19. 4.2. Central tendency and dispersion.
Dispersion. Yes, sir.
Okay.
Okay.
Fine. So in the first paragraph, I have written, we calculate the central tendency and dispersion for the quantitative variables that I have told earlier. Okay. Do you know central tendency and dispersion? These are two statistical terms. Central tendency includes mean, median, mode. Okay. And dispersion includes standard deviation, variance. Okay, also range. Range is also a dispersion. Central tendency indicates the average value of the data set, while the dispersion indicates the variability. How much is the variability in the data set? Okay, am I clear?
Variability means
Variability. How the
average থেকে কত দূরত্ব?
How the data varies from person to person.
Yes.
Remember that in statistics, variability is measured against the mean. Okay?
Yes, sir.
Variability is measured against the mean. Fine, I will discuss with you later. Okay. For example, you want to find the mean, median, mode, standard deviation, variance, standard error, skewness, kurtosis, quartile percentile, minimum and maximum values of the variable age of the study subject. All these statistics can be obtained in several different ways, as I told you. However, using the following commands is the easiest way to get those together. Acha. Now, if I ask you to find all these statistics for income, can you do it looking at the book? Under 4.28 number 19. Can you do it looking at the book?
Can you please repeat? I can't hear because of the noise.
Okay, please read the paragraph. I have just read it out for you.
4.2.
Yeah, under 4. So can you do the analysis looking at the book? Because my ultimate objective is to introduce the book to you so that you can do it when nobody is there to help you. Okay.
Using which variable, sir? Income.
Using instead of age, just use income. Okay. Instead of age, use income.
Okay, sir.
Okay.
Excuse me, sir. Can you hear me?
Yes.
Hello?
Yes.
In between, your sound is dropping and there are a lot of background noise. So many words are missing in between.
Okay. Please
It's
look
happening.
at page number 19 of the book. Page number 19, 4.2. Central tendency and dispersion.
I can't hear.
You cannot hear?
Yes, the sound is dropping.
Okay, let me mute everybody. And otherwise, now, can you hear me now? Hello?
Sir, for now,
Hello?
it's good.
Is better?
Yes.
Yes, sir.
Okay. Okay, please look at page number 19, 4.2. 4.2.
Done.
Okay, so if you please read the first paragraph. Here I have suggested.
Can't hear, sir.
What happened? Hello?
Sir, please adjust your microphone. Your sound is dropping.
Hear anything.
I think my microphone is okay. Can you hear me now?
Yes, sir. Loud and clear.
Yes, sir.
Okay, fine. Fine. So I am telling you to go to page number 19, 4.2.
That's a PDF or hard copy, man. Learning spaces without pain.
Whatever, the page number is same. Okay, page number 19. 4.2. Can you do the analysis that I have mentioned here? Only use income instead of age. That's all.
Done.
Can you repeat, sir?
Already done. Yes, sir.
It's okay. Okay, fine.
Please repeat.
আমি কবার বলবো?
স্যার কাট পয়েন্টস যেটা আছে এটার মানে মিনিংটা বুঝতে পারতেছি না।
I did not tell you any cut point. I am just telling you whether you can do it looking at the book or not. If you cannot do it, just keep it like this. Let us see how many can do it.
Yes, sir, I did it already.
Okay. Fine. So how many could not do it?
Done, sir.
Done? Okay, very good. So everybody has done?
Yes, sir.
Okay. Okay, very good. So you say, what I wanted to be sure is that whether you can use the book or not. That is the purpose. Have you got my point?
Yes, sir.
Throughout the book, the commands are written like this. Have you got it?
Yes, sir.
Okay. So if I do the analysis looking at the book, what is written first? What is written first?
Analysis,
Analyze.
Analyze, then
So I'm going to,
statistics.
so you see, I'm going to analyze, okay?
First,
then coming to descriptive statistics, then coming to frequency.
Yes.
Okay, you see, then I have written, select a variable age. Instead of age, I told you to select income, right?
Income. Yes, sir.
So let me reset it. Say, let me select income. Say income and push it into the variables box. So I am pushing it into the variables box, right?
Yes, sir.
Correct? Next, what I have written.
Statistics.
Statistics. So I'm clicking on statistics. Then I said that select all the descriptive
These are variable.
Right? Right.
Yes, sir.
Mean, then median,
Mode,
then mode,
SD,
standard
then
deviation,
standard
standard
deviation,
error, quartile.
then standard error,
quartile,
quartile. Here, quartile is
Percentage.
here, okay?
Yes, sir.
Quartile, then skewness is here, kurtosis is here.
Also
Then
percentage.
I
Percentile.
select percentile. I said, okay, select percentile. Okay,
30 and
I have
40.
selected percentile. Then write 30 in the
30.
box. So click here, write 30.
Add.
Okay, then
Yes, sir.
add.
Add.
Okay,
Yes, sir.
then
40.
okay, fine. Then write 40, again write 40, then add. Right? Then add. Then I said continue. Continue, then I said okay. So you will get the results.
Yes,
Have you
sir.
got my point?
Yes, sir.
So this is how the whole book is written. So if you can follow the book carefully, even you forget how to do it, I believe that you will be able to do it looking at the book. Have you got my point?
Yes, sir.
Yes, sir.
So, okay, fine. So I said that we can have all these statistics in several different ways. So this is one way how to get all these statistics. Am I clear? And
Yes, sir.
this is the most easiest way to do it. So this is the easiest way to do it. Okay, fine. Let us see. Let us see before interpretation, percentage. Acha, can you please go to page 22? Page 22.
Yes, sir.
Yes, sir.
4.3. 4.3. So can anybody read it out? Okay, let me read it out. If you want to generate all the descriptive statistics, central tendency and dispersion, and charts such as histogram, stem and leaf, and box and plot charts. For the variable age, use the following commands. Okay, that means if you want to get the central tendency, means mean, median, mode, dispersion, standard deviation, and charts like histogram, stem and leaf, box and plot chart. If you want all these things together for a variable, for example, age, you can get them using the following commands. So can you do it looking at the book?
Yes, sir, done.
Okay, please, done? Oh, very good. Very good. So try, everybody should try. Let us see.
Done.
Done? Very good. Very good. Everybody has done it. Everybody has. Oh, very good. So is it difficult or easy?
Yes, sir, done.
Okay, very good. My question is it very difficult or easy to do it?
It is more easy than previous one, frequency.
Okay, you see there are several.
In previous model, we have to select individual program, and in this option, we can only select one.
Okay, okay. So that's why I have said you have several options to get them together. So you see, SPSS is very simple. You can get the statistics that you want very easily. So it's not actually difficult at all. Okay, fine. So let me analyze it. Analyze, descriptive, explore, right? Explore. Say select the variable age, then push it into the dependent list box, then click on plots, stem and leaf, histogram, okay? Continue, okay. Continue, okay. So you can see that we are getting all these things together, okay? Fine. So far, any problem, any question?
So question is, how do I interpret this?
How? So I will be coming to that question point later on.
Okay, sir. Thank you.
Okay, so let us first try to know whether we can do it or not. So is it clear? Is it okay?
Yes, sir.
Any questions
sir.
so far? Any questions so far?
No, sir.
No, nobody? Okay, fine. If there is no question, you see, sometimes we may need all these statistics separately for example, for males and females, okay? Have you got my point?
Yes, sir.
Yes, sir.
Occasionally, we may need to have all these statistics separately for males as well as for females. Okay? Or say for the Muslims, for the Christians, for the Hindus separately. Am I clear?
Yes, sir.
Yes, sir.
We call it, for example, disaggregated by sex, means separately for each level of the sex, each level of the occupation. Okay, we can also do it. So to do it, go to analyze, descriptive, frequencies, explore. Go to explore. Click on explore. Okay. Done.
Okay, sir.
Yes, sir.
Okay. Say we want to get the mean, median, all those descriptive statistics of age by religion. Okay, we want to get them by religion. Therefore, religion would be considered as the factor list. Okay. In that case, religion would be the factor list. Factor variable. So select religion, push it into the factor list box. That's all. Have you got it?
Yes, sir.
Yes, sir.
Now, everything is already selected. You have selected everything previously. Okay. Just click OK. Click OK. Click OK. Now you can see, the computer has provided, you see, the descriptive statistics of age for Muslims. The mean is 26.9. Hindus, mean is 26.27. Christians, mean is 24.8, like this. So you can see that the computer has provided all the descriptive statistics by religion. Okay, have you got it?
Yes, sir.
Fine. So if I ask you now to find the descriptive statistics of systolic blood pressure by sex, can you do it?
Yes, sir.
Yes, sir.
Okay, do it, please. Descriptive statistics of systolic blood pressure by sex, disaggregated by sex.
Done, sir.
Done? Oh, very good. You see, so simple, so easy.
Done, sir.
Oh, very good. Very good. Very good. Just select systolic blood pressure.
Done, sir.
Oh, done. Very good. Then select sex here. That's all. And this is given in page number. Let me check something. This is given in page number 26 under 4.4. Okay. Is it all right?
Yes, sir.
Okay. So everybody could do it, right?
Yes, sir.
Okay, Dr. Uma, have you done it? Dr. Uma, could you do it?
Yes, yes, sir. My mic was mute. Sorry. Yes, I did.
Okay, okay, fine. So it's all right. Now, there are other ways to do it. Just let me show you, okay? Just let me show you. There are other ways to do it. For example, you can go to analyze, then compare means. You can do it with me. Analyze, compare means. Okay. Compare means, then click on means.
Yes, sir.
Okay, click. Have you done it? Click means. Are you with me? Is everybody with me?
Yes, sir.
Okay, so I'm clicking on means. Fine. Say I want to see the descriptive statistics of age by religion. So select age, push it in the dependent list box. Then select, say, religion and push it in the independent list box. Okay. Okay.
Yes, sir.
Yes, sir.
Then click on options. Click on options. Click on options. Options. Okay.
Yes, sir.
Remove from the cell statistics box number of cases. Just remove this one. So we can see mean and standard deviation are already here in this box, right?
Yes, sir.
Cell statistics. The other statistics that you want, select from the statistics box and push them into the cell statistics box. Say, for example, median. Okay, I have selected it and pushed it here. Okay, then minimum, maximum, okay, we don't need it, variance, huh? Or standard error, skewness, curve, whatever you want, you can select from here. You will also find, you see the standard deviation is there if you want, okay. Say kurtosis, you can select it, skewness, you can select it, okay, like this. Have you got my point?
Yes, sir. Yes, sir.
Then continue, okay. Continue, continue, okay, okay. Continue, okay. So you can see this table. Can you see this table? You see
sir.
the Muslim,
Yes,
Hindu,
sir.
Christian. This is the mean, this is a standard deviation, this is median, kurtosis, skewness. So simple. Okay, there are other ways. We don't need anything else. Fine. Am I clear?
Yes, sir.
Yes, sir.
Now let us try to interpret the results, which is very, very important. Okay, fine. We understand what is mean, correct?
Yes, sir.
Do we understand what is a standard deviation?
No.
Is it the deviation from
Mention the page
mean?
number of the last example. Compare means.
Sorry.
And the last example you have given, where you have chosen the compare means, I want to see the page.
Oh, you want to see the page. It is not directly given here. In the later part, it is given, okay? So forget about this one. You may not need this. You can have all the analysis using the other two methods. Okay.
Okay, sir.
So if you want it, you can write at the bottom of that page like this. Okay. You can write at the bottom, analyze, compare means, then means, okay? Like this. You can write a short note for yourself. Is it okay?
Okay, sir.
Fine. So now let us try to interpret. So standard deviation, what does it mean, standard deviation?
Is it the square deviation from the mean?
Okay, practically, what does it mean? Practically.
Variance
So
of the data.
Deviated from the center.
Okay, so actually standard deviation indicates how much is the variability in the data set. And as I have mentioned earlier, variability is measured against the mean, Therefore, the standard deviation indicates the average difference of individual observation from the mean. Average difference of individual observation from the mean. So it is written here. Standard deviation indicates average difference of individual observations from the mean. Okay. Okay.
Yes, question.
Yes,
Sir?
please. Yes.
Sir, what is the significance of knowing this?
Okay, what is the significance of knowing this? Who is asking this question?
Me, Uma, sir.
Umadi. Okay, fine. Suppose you are very much fond of cricket. Okay. There is a cricket match between Pakistan and India.
Yes, sir.
Okay. India is now struggling. They want a batsman who is consistent. Okay. India needs some run. Okay. Say around 30, 40 runs they want. They have two players. Both of them has the average of 30. You see, they are giving these statistics. Say number of games played, average runs. Do you, do you mark it? Say two players. Both of them have the average is 30.
Yes,
okay. And the standard deviation of player one. Okay, who is your favorite cricketer, Indian cricketer?
I don't remember now because it's 14
Okay.
years. I'm now in West Indies, no?
Oh, you are now in West Indies. Okay. Okay. Say,
So better name a West Indian cricketer.
Sachin Tendulkar, boss. No, I'm Indian by heart. Passport.
Okay, okay, I tell you. Fine.
Tendulkar.
Say, okay, Tendulkar is retired. Fine. Okay, Tendulkar, and now who is the best Indian batsman now? What's his name?
Virat Kohli.
Virat Kohli. Say both of them has average 40 runs. Okay. Tendulkar has standard deviation 5. Mean is 40 runs, standard deviation is 5 runs. Virat Kohli average is 40 runs, but standard deviation is 10. Okay. Now, who you are going to select?
Tendulkar.
Why?
Because his standard deviation is less, so it is highly unlikely that he will score. Instead of 40, 30, he might score 35. More.
Exactly. Exactly. In such a situation,
he's more consistent. He's more consistent.
Exactly. Then we can expect that, well, he will have a score around 40 anyway. Okay. But if we select Virat Kohli, then he might score instead of 40, 30, or maybe 50. But if we select Tendulkar, he might score, say, 35 to 45 like this. I give you another example. Say, since you are a clinician, you have 2 drugs to reduce the blood pressure, okay? The literature says that both the drugs on an average reduces 5 millimeter of mercury, okay, of systolic blood pressure. But the standard deviation of drug A is 1 and standard deviation of drug B is 3. But you need a drug and you want to be sure that this drug would at least reduce the blood pressure to some extent. Which one you want to select?
One with the 1.
Yes, because the variability is less, okay? So that is the application of standard deviation to understand how to select. Am I clear? Am I clear?
Yes, sir.
Okay, so this is a standard deviation. Fine. So if we look at the table, you can see, so 95% confidence interval of the mean. So what does 95% confidence interval indicate? Can anybody?
95%
Yes.
confident that the sample is representative of the population.
Well, actually,
95%.
Yes,
95% of the values will be fall in this range.
Okay. Values means which values?
Mean, sir.
Mean.
Okay. Actually, if we look at the definition of statistics, by definition, statistics is the science, or the statistics is the process of collecting data, compilation and analyzing data, and to conclude about the population by taking a sample from that population. That means we want to have an idea about the whole population, but by studying only a sample. Am I clear?
Yes, sir.
For example, suppose you are cooking firni. Whether the firni is adequately sweet or not, do you want to eat the whole firni or only a small part of it?
Small part of it.
Small part.
That is the sample.
Okay. If you eat the whole firni to understand whether it has become sweet or not, then there is nobody else to eat it, okay? So that is the beauty of statistics. We take a small part. For example, so while cooking rice, we test a couple of rices, 1, 2, or 3 rices to understand what is the situation or condition of the rice in the pot, okay?
Yes,
Am I
sir.
clear?
Yes, sir.
Okay, suppose I am interested to know what is the mean age of the participants in this course. And we know that there are 30 participants attending the course. Now I have 2 options. I can collect information on age of all the individuals and calculate the mean. I can do it like this. Alternatively, using the statistical method, I can take a sample of 5, 3, 4, whatever it may be. I can take a sample of 5 individuals randomly, collect the age of those 5 individuals, and I calculate the mean. Am I clear?
Yes, sir.
So if I select everybody and calculate the mean, and if I select a sample and calculate the mean, will those means be same?
No.
No. Everybody agree?
Yes, please.
Huh?
No,
Would it be
no.
same? No. Huh?
No,
Would
it
it be
won't be.
same? It won't be. Most likely it would not be same. Accidentally it can be same. Accidentally. We call it rare event. Okay. But which one is the actual value?
When average is done from the total.
Total. That is the actual value, right?
Yes.
But if we calculate it from the sample, and you said that the sample value and the population value, that is actual value is the population value. Actual value and the sample value is not the same. Okay, you said it.
Yes,
Did
sir.
you? You said it or not?
It will not be the same.
Yes, that is what I'm telling. You said that it would not be the same. Therefore, there is always a difference between population value or the true value or actual value, whatever you say, and the sample value. There is a difference, okay? Huh?
Yes, sir.
Okay, that difference we call sampling error. Okay, we call it sampling error. Therefore, the sampling error is the difference between the sample value and the population value. Am I clear?
Yes, sir.
So which one actually we are interested to know?
The real value.
The real one, correct?
Yes, please.
But every time we want to know the real one, everybody is giving us the sample value, which is not true. Because everybody is working with a sample. Am I clear?
Yes, please.
But we want to know the population value. Okay? In statistics, we can give the population value by two measures. I think I don't know whether I'm making it complicated or not.
No, it's okay, sir.
Okay, fine. So we can give this population estimation by two methods. One we call by point estimate, another is called interval estimate. Okay, point estimate and interval estimate. Point estimate is the value that we calculate from the sample. Okay. Okay, am I clear? And we are considering the sample value as the population value since we do not have any other options. Okay, we don't have any other options. However, we believe that if we conduct the study properly following the scientific method, then we believe that even though the sample value is not same as the population value, but it would be close to the population value. Am I clear?
Yes, sir.
Therefore, remember that a statistic is not the true value. A statistic is not the true value. By definition, a statistic is the descriptive statistic, descriptive measures that we get from sample. Okay? The descriptive measures that we get from sample is called a statistic. While the descriptive measures that we get from the population, if we measure the whole population, we call it parameter. Exactly. We call it parameter, but they are not the same. Okay? But we believe that a statistic that we are using would be close to the population value. That's why we are using it. Therefore, a statistic is not the true value, but we say that it is an estimation of the true value. Anuman, andaj, estimation, okay? It is an estimation of the true value. If you carefully listen to the presentations that people are making in different conferences or seminars, you will see that nobody is telling this is the true value of this. This is the true mean. Nobody says this. They say that it has been estimated that the mean age is this, okay? The prevalence of disease is this. They always use the word estimated that, because from the sample that we collect, the descriptive measures is not the true value. Now the question is, however, we are actually interested to know the true value. And to give the true value, you know, the statisticians are very intelligent people. Then they have proposed the interval estimate. They use the interval estimate. In interval estimate, we give the estimation by two values. One is lower value, another is upper value. So it's a range. Am I clear? So we give the interval estimate by a range. If we give it by a range, there should have a lower value, there should have a upper value. However, we shall have to give certain amount of guarantee. Okay? We shall have to give certain amount of guarantee. If we give a guarantee of 95%, and if we say that it is between this and this, then we call it 95% confidence interval. Am I clear?
Yes, sir.
Okay. Here, if our statistics say that the 95% confidence interval of the mean is 25.4 to 27.5, it indicates that we are 95% sure. Okay, we are giving you 95% guarantee that the population mean, that is, if you could measure the whole population, the true mean would be somewhere between 25.4 to 27.5. Okay?
Yes.
Am I clear?
Yes, sir.
But there is a chance of 5% that the population mean may be beyond this range. Okay? Maybe beyond this range. Am I clear?
Yes, sir.
So if you go through my book, you will find not such kind of details, but we have provided the information like this, that 95% confidence interval for mean indicates that we are 95% confident that the population mean lies between, say, 25.4 and 27.5. Okay? Something like this. Am I clear?
Yes, sir.
Okay. So next statistics we can see is 5% trimmed mean. Can you see that 5% trimmed mean? Hello?
Yes, we can see.
Yes.
Hello. So what is 5% trimmed mean? Okay. Before that, let us construct the box and plot chart for systolic blood pressure. Okay. Okay. Systolic blood pressure and age. How to do it? Go to analyze, descriptive statistics explode. Okay, please do it with me. Are you with me?
Yes, sir.
Yes, sir.
Explode.
What was the
Okay.
variable, sir?
Systolic blood pressure and age. So I have put it, say, take out 6 from the factor list box. Okay. So can you see it? Systolic blood pressure, age. Okay. Are you with me? Can you see my
Yes, sir.
computer? Okay. So are you here, already here?
Yes, sir.
At the bottom, you see display. Under display, both is selected, right? Let us just select the plots, only plots. Select the plots. Have you done it?
Yes, sir.
Select the
Yes,
plot.
sir.
Now click on plots here, plots. Click on plots here. Okay. Have you done it?
Yes, sir.
Plots. Select, deselect histogram. Only keep stem and leaf selected. Okay. Okay.
Yes, sir.
Then continue. Continue. Okay. Okay. Continue. Okay. Fine. So omit this one. This is stem and leaf. Go to the next. This is what we call box and plot chart. This is for systolic blood pressure. Okay. Okay.
Yes,
Have you
sir.
got it? So go to the box and plot chart of age at the bottom. Okay. Okay. Are you here with me?
Yes, sir.
Okay. We can see there is a box at the middle. Okay. We can see there is a box at the middle. The lower border of the box indicates Q1 or quartile 1. Lower border indicates Q1. Clear? The upper border indicates Q3 or third quartile. Q1 is the first quartile. Q3 is the third quartile. Clear?
Yes, sir.
Okay, just a minute. Let me find it out for you. Okay, can you go to page 24? I have given a figure 4.9. Page 24, figure 4.9.
Sir, পেয়েছি.
Okay, so it is leveled there, okay? Lower border is Q1, upper border of the box is Q3. The middle one is the median or Q2, okay? The line in the box indicates the median or Q2, okay? Am I clear?
Yes, sir.
Yes.
Yes, sir.
These lines are called whiskers, WHISKERS, okay, whiskers. And the lowest line indicate the lowest value, upper one indicates the upper value, okay? Clear?
স্যার আরেকবার একটু বলে ভালো।
এটা উপরের লাইন হলো আপার ভ্যালু, নিচের লাইন লোয়েস্ট ভ্যালু, হাইয়েস্ট ভ্যালু, লোয়েস্ট ভ্যালু, দ্যাটস অল। ওকে,
স্যার ফার্স্ট কোয়ার্টাইল, সেকেন্ড কোয়ার্টাইল, থার্ড কোয়ার্টাইলে যে বর্ডার লাইনটা ওইটা স্যার আরেকবার দেখাইলে ভালো।
এটা তো বইতে এতক্ষণ বলতেছি রে, বইতে তো বললাম Q1 Q2 Q3 লেখা আছে না 24।
24 পেজ আপু।
হ্যাঁ, এই যে বলেছি
Okay,
যে
sir.
লোয়ার বর্ডার ইজ Q1, আপার বর্ডার ইজ Q3, মিডল ওয়ান, মিডল লাইন ইজ Q2। ঠিক আছে?
Okay, sir. Thank you, sir.
Okay, now you see, now look at the systolic blood pressure. You see there are some, what should I say, rounds like this. Huh? Can you see there are 3 rounds?
Yes, sir.
And it is written 20, 54, 193. Okay, is it written like this?
Yes, sir.
So
Yes, sir.
this indicates the outliers. Okay, in systolic blood pressure, there are 3 outliers. And the ID number of the outliers are 20, 54, and 196. What is outlier?
মিন থেকে অনেক দূরে।
There is no
Okay.
other number that matches in the observation list, I think.
5% এর মধ্যে পড়ে স্যার।
These are the unusual values which are different from the common values. Okay. This is theoretically, but practically in SPSS, the outliers are the values which is greater than Q3 plus 1.5 into IQR, interquartile range. Okay, let me write it, otherwise you cannot get it. So the outliers are the values which are greater than say Q3 plus 1.5 into IQR, or less than Q1 minus 1.5 into IQR. Okay. Now, what is IQR? IQR is interquartile range. Range, which is equal to Q3 minus Q1. Okay. Is it clear?
Okay, sir.
Now, let us look at our data. Okay, let us analyze. Let me do it to get it here. So here I shall select only the statistics is okay, then I will do it. Okay. So you can see that for systolic blood pressure, IQR, can you see interquartile range? Okay, can you see the interquartile range?
Yes, sir.
What is this? It is 20, 28. But we do not know what is the Q1 and Q3, right? So to get the Q1 and Q3, can you find it? We have done it earlier. You see frequencies. Do you remember? Descriptive frequencies. Say
Minimum, maximum.
No. Systolic blood pressure, then age, then we went to statistics, a percentile quartile, okay? So if we just select quartile, deselect others, we shall get the, okay? We shall get the quartile. Have you got it? Do you remember? We did it earlier. Okay?
Yes, sir.
Say continue, okay. Now you can say percentile 25 is Q1. Do you know it?
Yes, sir. Yes, sir.
Huh? Everybody?
Yes, sir.
Okay. Quartile, what is quartile? Quartile is if we divide the data set into 4 equal parts after ascending order, then each part is called a quartile. Clear? If we divide the data set into 4 equal parts, if we divide the data set into 4 equal parts, order, each part is called a quartile. Okay? Am I clear?
Percentage.
Okay? Am I clear?
Yes, sir. Now, yeah. Yes, sir.
Okay.
Yes, sir.
Therefore, you see, the 25th percentile is the first quartile. Huh?
Yes, sir.
50th percentile is the second quartile. 75th percentile is the third quartile. Okay? Clear?
Yes, sir.
Huh? So we can see that the systolic blood pressure Q1 is equal to 113.75 and Q3 is 142. So if you deduct 113.75 from 142, you will get the interquartile range, which is around 28. Okay? Have we got it?
Yes, sir.
So now I said that we shall say that outliers are equal to, since the outliers are located at the upper side, okay, located at the upper side. So it should be greater than Q3, because this is Q3 plus 1.5 into IQR. So IQR is equal to 28. Therefore, the outliers that have been indicated in the data should be the values greater than 142 plus 28 into 1.5. So how much it would be?
42.
No, it's for 142 plus. Well, I'm making it complicated, I think. Into 28 into 1.5, which is equal to greater than 146.2. Okay, anyway, just theoretically, we say that the outliers are the values which are greater than Q3 plus 1.5 into IQR, or less than Q1 minus 1.5
into
IQR. Okay, you will find them in the book. Am I clear?
Yes.
Interquartile range is the value Q3 minus Q1. Okay. Now, what is trimmed mean and what is its use? That is the question. Trimmed mean means if we discard 5% of the upper value and 5% of the lower values of the data, then if we calculate the mean, it is called trimmed mean. Am I clear?
Yes, sir. Yes, sir.
If we discard 5% of the upper value and 5% of the lower values, okay, if we delete them, then if we calculate the mean, then it is called the 5% trimmed mean.
25, 2.5 and 2.5 or 5?
No, I am telling 5%. 5%, 5%, total 10%. Okay, am I clear?
Yes.
Is it okay?
Yes, sir.
Am I making it very complicated or not? Hello?
No, sir, it's not complicated, just new. Just new to us, me.
Okay, the thing is that if you take out or delete 5% of the upper data and 5% of the lower data, lower values or data, whatever you say, then if we calculate the mean, it is called the trimmed mean. Okay, you know trim er bangla ki? Bangla holo chete dewa, কেটে দেওয়া। ট্রিম করে বলি না আমাদের চুলটাকে ট্রিম করব, ট্রিমার, ওই যে আমরা যে ইউজ করি ট্রিমার। ওকে, am I clear? হ্যাঁ, কি ঠিক আছে? হ্যাঁ, হ্যালো।
ঠিক আছে, কিন্তু এর পরের প্রশ্ন হচ্ছে ট্রিমটা কিভাবে করছে?
কেন? Why we are absolutely. First of all, let us understand what is trimmed mean. So, are you clear what is trimmed mean?
Not yet, sir.
No, what is the question? What is the question?
Sir, I have a question.
Yes.
Are we trimming the value from the confidence interval mean, or
I did not, I have never said about confidence interval. I have said just delete data of 5% upper value and lower value, then calculate the mean. It is the trimmed mean, 5% trimmed mean.
Sir, after doing percentile, how can you trim?
কি বলছেন বুঝতে পারলাম না।
পার্সেন্টাইল বের করে তারপর করব?
ওটা that computer will do it for you. Why do you worry about it? Computer is doing it for you automatically. Computer programming is set like this. You don't have to do it separately.
Yes.
Okay. Have you got it?
Yes, sir.
Okay. The question is, suppose there are 3 persons, okay? The body weight of one person is, say, 50 kg, another person is 52 kg, another person is 54 kg, okay? So what did I say? 50, 52, 54 kg, correct?
Yes, sir.
So what would be the average? What would be the mean?
Average is 52.
52 kg. Now, instead of the person who has 54 kg, if there is a very fat person, instead of the third person whose body weight is 120 kg, what would happen to the mean?
It will not reflect the real scenario.
No. Mean ta ki hobe? What would happen to the mean?
Mean will be so high.
Mean would be?
Very high.
Okay, mean would increase. Okay,
Yes.
correct? That means mean is affected. So this is 120 kg person is not the usual person. It is an outlier. Okay?
Yes, sir.
Have you got it? I said that outliers are the values which are very different from the values within the data set. Okay? So 120, the person whose body weight is 120 is an outlier in this case. Clear?
Yes, sir. Yes, sir.
So we see that if there are outliers in the data set, it influences the mean. Okay? If
Now
the
it is 69.
if the outliers are at the upper side, the mean tends to increase, while if the outliers are at the lower side, the mean tends to decrease.
Yes, sir.
Okay? Yeah. Now the question is whether the outliers has influenced the mean of the data set or not. To understand this, we compare what is the mean and what is the trimmed mean. Okay?
Yes, sir.
So if these two means are close together, then we consider that even though there are some outliers, they do not have big influence in the mean of the data set. Okay?
Yes, sir.
Yes, sir.
Now, have you got the purpose? Why do we want to need this? We want to see this.
Yes, please.
Yes.
The purpose is we want to know whether the outliers present in the data set has an influence to the mean or not. And to see this, we shall compare what is the mean of the data set and how it is different from the trimmed mean. If these two means are close together, then it indicates that even though the data set has outliers, it does not have any influence. I mean, any significant influence to the mean. Okay?
Yes, sir.
Clear?
Clear.
Okay, fine. Now, let us see what is, okay, fine. So we have explained mean, 95% confidence interval, trimmed mean, we know median, correct?
Yes, sir.
It is the middle value of the data set, which divides the data set into upper 50% and lower 50%. Okay? Variance is the square of the standard deviation. We have explained the standard deviation. Minimum, maximum. Range is equal to maximum minus minimum. Okay. 195 minus 91 is equal to 104. Interquartile range, I have explained. Now, skewness and kurtosis. Okay. Do you have any idea about skewness and kurtosis?
It affects the distribution curve.
Okay, very good. Actually, looking at the statistics for skewness and kurtosis, we can have an idea whether the data is symmetrical or not. Okay, to understand whether the data is symmetrical or not. Symmetrical means normally distributed or not. And perhaps all of you know the characteristics of normal distribution. At least you know that the normally distributed data looks like a bell-shaped curve. Okay? Bell-shaped curve like this. Say like this. This is normal distribution. We also call it symmetrical distribution. Clear? Okay. Am I clear?
Yes, please.
Okay. The skewness indicates spreadness of the distribution. Spreadness. Here I think I have written. Okay, indicates spreadness of the distribution. Okay. So if the distribution is like this, we can see that there is a tail, extended tail on the left-hand side. Okay, here. Left-hand side, there is an extended tail and the curve is not symmetrical like this. So this is what we call skewed to the left or negatively skewed. Okay. If the tail is on the left-hand side, then we call it negatively skewed or skewed to the left. On the other hand, if the distribution shows that the tail is on the right-hand side, then we call it skewed to the right or positively skewed. Clear?
Yes, sir.
Huh?
Yes, sir.
Well, unfortunately, I'm very sorry because you say unless there is some statistical informational knowledge, sometimes it would be very difficult to understand. Okay, but I'm trying to explain it as simply as possible. Okay, for example, we can check the distribution of data by constructing a histogram. We can see the histogram here. Okay, let me construct the histogram for systolic blood pressure. So you can do it with me. Graphs, then come to legacy, dialogue, then come to histogram. Please follow me to construct the histogram for systolic blood pressure. Are you following me?
Yes, sir.
Click on histogram. Click on histogram. Click. Okay. So we shall construct the histogram for systolic blood pressure. So select systolic blood pressure, push it into the variable box. Done it? Have you done it?
Yes, sir.
Select display normal curve under this here. Select display normal curve. Have you done it?
Yes, sir.
Everybody?
Yes, sir.
Okay, just click OK. Just click OK. So you can see. What do you see? If we look at this histogram, what do you see? If the systolic blood pressure were perfectly normally distributed, all these bars were within this curve. Okay, have you got it?
Yes, sir.
All these curves were within this curve, Okay, let me construct the histogram without this curve, then you will get a better impression. Now I'm just deselecting this one, okay? Just deselecting this one and doing it again. So you can see like this. Now, if I make a curve, this is called frequency polygon, okay? This curve is called frequency polygon. So it would be like this. You see, it seems that it is skewed to the right. Huh? Does it look like this? There is a tail on the right-hand side.
Yes, sir.
That means that this data is skewed to the right.
Positively skewed.
Positively skewed data.
Positively skewed. Agree with me?
Yes.
Yes,
Okay. Say it is like this. Okay. Fine. Similarly, the data can be negatively skewed. Okay, the tail may be on the left-hand side. Then we call it negatively skewed data. Clear?
Yes.
Okay.
Yes, sir.
So this is what we call skewness. Skewness indicates spreadness of the distribution, while the kurtosis indicates the peakness, okay? Peakness of the distribution. The kurtosis indicates the peakness of the distribution. For a normal distribution, the peakness should have a standard peak. It should not be very peak or it should not be flat like this, okay? If the curve is flatter, then the standard normal distribution, then we say that skewness is less than 0, okay? Which is called platycarty. Actually, we don't need it, okay? Have you got it? Actually, we don't need it. Platycartic, leptocartic, mesocartic. Mesocartic is the normal peak. That means the standard peakness for the normally distributed data. If it is more peak than the normally distributed data, we call it mesocartic. And if it is less peak than the normally distributed data, then we call it platycarty, okay? The simple thing is that looking at the skewness statistics, we can have an idea. You see here, you can see that skewness for systolic blood pressure is how much? 0.736, correct? How much?
Yes, sir.
0.736.
0.736, and it is positive, okay? It's not negative. If it were negative, there would have a negative sign here. So we do not see any negative sign. That means it is positive. Clear?
Yes, sir.
And we have seen the histogram that the systolic blood pressure has the skewness to the right. Okay? So if the skewness is to the right, then the skewness statistics is positive. Okay? So skewness positive means it is skewed to the right. Clear?
Yes.
Okay. Now the question is, since we are working with the sample from the population, ideally, if skewness is equal to 0, then it indicates that data is perfectly symmetrical in the population. Let me repeat. If the skewness statistics is equal to 0, then it indicates that the data is perfectly symmetrical, that is normally distributed in the population, if it is 0. But it is not 0 since it is 0.736. Therefore, we assume that the data is skewed, a little bit skewed to the right. Okay. However, as I have mentioned earlier, that since we are working with the sample, therefore it would be different from the population. Normally, we consider that if the skewness statistics is in between -1 and +1, if the skewness is in between -1 and +1, we can consider that the distribution of the data is symmetrical. Clear?
Yes, sir.
Clear?
Yes, sir.
Say, I have written it here. So you can see indicates spreadness of a distribution. Acceptable range for a symmetrical distribution is -1 to +1. Okay?
Yes, sir.
Similarly, for the kurtosis, if the statistics is equal to 0, then it is the perfect, that is, it is mesokurtic, okay? It is mesokurtic. That means perfectly distributed. But however, if the range is within -1 and +1, we can consider that the kurtosis is also consistent with the normally distributed data. Am I clear?
Yes, sir. Yes, please. Yes, please.
In conclusion, okay. In conclusion, if you want to understand whether your data is normally distributed or not, okay? Because this is one of the important issue I will also further discuss. So we may be interested to know whether my data is normally distributed or not. To understand whether my data is normally distributed or not, we can use statistics like this, skewness and kurtosis. We can also decide whether the data has come from normally distributed population or not by looking at the graphs, like histogram, like box and plot chart, like this. Okay, we can also, there is also another option by constructing the QQ plot. There are several options. And third option is we can also do a statistical test of hypothesis to understand whether the data has come from normally distributed population or not. Am I clear?
Yes, sir.
Okay, let me show you. You see the first quartile or Q1. Okay, what does it indicate? First quartile, second quartile, third quartile. Do you understand?
জি স্যার স্যার আজকের মতো যদি স্যার মানে থাকতো স্যার তাহলে মনে হয় ভালো হতো
কি করলে
স্যার মানে স্যার অনেক
হ্যাঁ বলেন
স্যার ক্লাস হচ্ছে যদি স্যার আজকে মানে এই পর্যন্ত থাকতো তাহলে স্যার মনে ভালো হতো
তাহলে না শেষ হবে না এই যে আরেকটু পরে শেষ করে দিব just another 5-10 minutes okay I will finish it.
Yes, please carry on.
Fine. So, okay, fine. Before that, let me, you see, descriptive. Okay. So how to understand whether the data has come from a normally distributed population? Okay. There are three options. Number one, we can have an idea whether the data has come from a normally distributed population or not by using the descriptive statistics like skewness and kurtosis. Okay, that I have discussed. I said that if you see that the skewness value ranges from -1 to +1 and kurtosis value also ranges from -1 and +1, then you can assume that the data is symmetrical. Am I clear?
Yes.
Am I clear? Second
Yes,
is,
sir.
we can also look at the histogram and QQ plot. We can also use the box and plot chart to understand whether the data is more or less symmetrical or not. Symmetrical means normally distributed or not. For example, just now we have seen a histogram and we see that it is a little bit skewed to the right. Okay, so you can have an idea. Okay. And we can also do a formal statistical test like Shapiro-Wilk test, Kolmogorov-Smirnov test, to understand whether the data has come from normally distributed population or not. Okay?
Yes.
Okay. Now, what is Q1? Say, if we look at our data, for example, say, have you find, say, Q1 is 113.75. It is for systolic blood pressure, okay? And Q1 is 21 for age. What does it mean? If I say that the Q1 for age is 21 years, what does it mean?
Again, please.
What does it mean if Q1 is 21?
25% population average টা হলো 21 mean.
Okay.
Yes,
okay. Sir. Okay. No, actually it indicates that 25% of the observations has age 21 or less than this. Okay, it's not the average. Okay.
Again, sir.
The age of 25% of the study subjects is 21 or
less
than 21 or below 21. Okay, so it is written here. Say, if Q1 for age is 21, it indicates that the age of 25% of the study subjects or observation is less than or equal to 21 years. Okay? Clear?
Yes.
So, therefore, if it is, suppose, if Q3 is 21, if Q3 is 21, then it indicates that instead of 25, it would be 75.
75.
Yes. Of the study subjects, age is less than
21 years.
Equal to 21 years. Okay. So as I have already discussed, the 5% trimmed mean is the mean of the data set after discarding 5% of the upper and 5% of the lower values. Okay?
Yes, sir.
Okay. We have also discussed about the outliers. Fine. Have we discussed about our outliers? That we can identify the outliers. This is the easiest way to identify the outliers by constructing the box and plot chart. There are other methods of identifying the outliers. There are other methods. Forget about those methods. It's a very convenient and simple method to identify the outliers in the data set by constructing the box and plot chart. Okay?
Okay.
Fine. So can we conclude here? But before conclusion, do you have any question? I know this session was a little bit complicated, but still, maybe I shall review again in the next class about all these statistical issues. Okay, any question?
No, sir, thank you.
Any question from anybody?
No, sir, so far.
Uma, are you clear? I know you are not from a statistical background, but
it is okay.
But these are not difficult things, simple things, but necessary things.
Yes, it needs some practice.
Yeah, practice is important. Right.
Absolutely, absolutely. And
This is
if
very
you
simple
please,
one. It's very simple.
Yeah, and if you please go through the book, you will get the answers of everything that I have discussed here today.
Yes, please.
But still, if anybody has any question, please you can ask the questions. And hope I shall review it again in the next class.
Yeah, that will be better.
Okay,
Thank you,
I will do it. I will do it. No problem.